Okay, let us solve some questions in momentum. The first question says a car of mass 1500 kilogram moving at 75 meter per second on a highway collides with a stationary truck of mass 6000 kilogram and sticks to it. What velocity does the wreckage move forward at? So now when you read these questions, you should keep in mind the directions of the moving objects. Now the car is moving at 75 meter per second. So let's assume that the car is moving forward. So the velocity of car will be positive 75 meter per second. Now the stationary truck is having a velocity of 0 because the truck is stationary before collision. Then after collision, what's happening? Mass and stationary truck, they are sticking together. So which means both the masses will add up after collision. So what velocity does the wreckage move forward at? So we know that final velocity has a direction which is moving forward. So let us apply the law of conservation of momentum to this question. So the momentum before collision, what is the momentum of the car? Mass times velocity. So 1500 times 75 because it's moving forward plus momentum of the truck is 6000 times 0 because the truck is stationary, it is not having a velocity, so the initial velocity of truck is 0. Now after collision, what's happening? It is sticking, so both the car and the truck are sticking together, and then they are moving with the same velocity, which is v. Let's solve for this. So this becomes 112,500 plus 0 will be equal to 7500 V, or your V will be 112,500 over 7500. So your V will be 15 meter per second. So both the truck and the car after collision, the total wreckage moves forward with a velocity of 15 meter per second. Now when solving for this, if you have applied the proper signs to both to the velocities, the final answer will show whether the velocity is positive or negative. So here the final answer gives a positive velocity, which means it matches the question that the wreckage is moving forward. Next scenario, a car of mass 1500 kilogram moving at 75 meter per second makes a head-on collision. So this is what is important. Head-on collision means with a lorry of mass 6000 kilogram moving at 16 meter per second. So both the truck and the lorry are moving, but the difference is that from the previous question is that in the previous question, one of the truck was stationary and the car was moving, but here the car is moving, this truck is also moving, but the truck is moving towards car. That's why it's making a head-on collision. So let's then it says calculate their common velocity after the collision if they remain attached. So again, here they have not discussed in what direction the car and the truck is moving, but they have said that they are remaining attached. So let us apply the conservation of momentum. The momentum of the car before collision is 1500 times 75, and the total momentum will be the momentum of the car and the truck added. So what's the momentum of the truck? 6000 multiplied by what's the velocity? Minus 16, because the truck is moving towards the car. So both of them are moving in the opposite direction. So if you assume a car to be moving forward, then truck will be moving backwards. So this will give us a value of 112,500 minus 6000 multiplied by 16 will be 96,000. So this will be the total momentum before collision. What is the total momentum after collision? After collision, what's happening? They both are sticking together. So 6000 plus 1500, and they're moving together, they're sticking together and moving. So they're having a common velocity. Let us assume the common velocity to be v. So this becomes So we come up with an equation as shown on the screen. So this becomes 16500 will be equal to 7500 V, or V is 16500 over 7500. So that is equal to 2.2 meters per second. Now if you look at it, we have the velocity to be 2.2 meter per second. It's plus 2.2 meters per second. So which means both the car and the truck, after collision, they are moving forward. Let's look at another scenario. In a football match, a defender running away from a goalkeeper at 7.5 meter per second is hit in the back of his head by the goal kick. The ball stops dead and the player's speed increased to 10 meter per second. How fast was the ball moving before it hits the player's head? So we need to find out the how fast was the ball moving before, so which means the initial velocity of the ball. Now let's assume the player is moving forward, okay, and the ball is also moving in the same direction as player, and it is hitting the player's head. Okay, after hitting the player's head, what happens to the ball? The ball is dropping dead, which means it's falling to the ground, so it remains stationary after collision. So this is what we understand from this example. Now after hitting the player's head, the player's speed is increasing to 10 meter per second. So the player is still moving forward with a speed of 10 meter per second. From 7.5 meter per second, the player's speed increased to 10 meter per second. So let us apply law of conservation of momentum to this scenario. What is the momentum of the player? The momentum of the player is mass of the player multiplied by the velocity of the player plus what's mass of the ball? The mass of the ball is in grams, whereas the mass of the player is in kilograms. So we have to convert grams to kilograms. So 4000 grams is 0.4 kilograms multiplied by the velocity of the ball. We do not know. We have to calculate the velocity of the ball because that is what the question asks. How fast was the ball moving before it hit player's head? Now, once it is hitting the player's head, what happens to the player? The speed of the player increases from 7.5 to 10, and what happens to the ball? The ball is falling to the ground, so the speed of the ball is 0. 562.5 plus 0.4 u is 750, or 0.4 u is 750 minus 562.5. 0.4 u is 187.5. U is 187.5 divided by 0.4, which will give you 468.75 or 469 meter per second. So this is the velocity of the ball before it hit the player's head. Okay. A gun has a recoil speed of 0.5 meter per second when firing. What do you mean by recoil speed? Recoil speed is a speed with which the gun moves backward when it is fired. Okay, so the recoil speed, so it is when we say it's moving backward, the velocity becomes negative. So the recoil speed of the gun was 0.5 meter per second. If the gun has a mass of 3 kilogram and the bullet has a mass of 20 grams, what speed does the bullet come out? So the bullet is coming out, so it's moving forward. So applying law of conservation of momentum. So initially, before firing, both the gun and the bullet is at rest. So both of them, the momentum of both gun and bullet before firing is 0. So the momentum before will be 0. What is the momentum after? So the gun is moving backward, whereas the bullet is moving forward. So when we calculate the momentum of the gun after firing, it's 3 multiplied by minus 0.5 plus, you have to convert again grams to kilograms. So 20 grams is 0.02, which is the mass of the bullet, and the velocity of the bullet we have to calculate. So that's V. Okay, now we know the bullet is moving out, so it's moving forward. That's why we are given a positive sign for V. So solving for this becomes 0 equals to minus 1.5 plus 0.02 V, or 1.5 equals to 0.02 V, or V is 1.5 divided by 0.02. So the velocity of the bullet is 75 meter per second.